Alright, let's look at some vocabulary for our functions. Asymptotes. An asymptote occurs when a function approaches positive or negative infinity at a specific value of x and y. We're going to write the equation of the asymptotes for the given equations. Alright, if you look at this following equation, you can see kind of how it seems to level out here as it approaches negative infinity. That's where an asymptote is going to be. An asymptote is like an invisible line that our graph is not going to cross. Now, right now, how we're going to denote that there's an asymptote, because we don't have the equations, there's going to be a dotted line that represents our asymptote. Alright, so this particular graph only has the asymptote at -2. So it doesn't have a vertical asymptote. This graph is going to continue to grow, so there's no vertical asymptote. But there is a horizontal asymptote at y equals -2. You must write your asymptotes as equations. So you must have y equals. Alright, B is an example where there is two asymptotes. See how the graph, there's a gap in our graph, a discontinuity in our graph at -2, and also a break in our graph at -1. Here again, right now, we will denote asymptotes by dotted lines. These dotted lines will be in your homework and on your quizzes. Alright, so the vertical asymptote equation is x equals -2, and the horizontal asymptote is y equals 1. I'm sorry, -1. Alright, one more example. Here's our asymptote, so dotted in a line at 3. It's vertical, so that's x equals 3, and there's no horizontal asymptote. Alright, let's look at some more domain and range. We're going to write our domain in interval and in set notation. Alright, look at A. Now remember, domain deals with our x values. So we look at our graph and see we have values to the left, and the arrow means it keeps going, and values to the right, and our arrow means it keeps going. So our domain is all reals. So our x is in between positive and negative infinity, which means another way of saying this is all reals. There's no restriction on our domain. So in interval notation, it's negative infinity to positive infinity. And remember, it's always open at infinity, so that's why it's parentheses and not brackets. Alright, but our range has a low value. It looks like to be about -4. And then it continues up to infinity. So in our range, it's going to be y. It includes -4, so greater than or equal to -4 in set notation. And then in interval notation, we want to bracket a -4 to infinity and then a parenthesis. Remember, bracket means it's closed and includes the value. Alright, example B. Alright, look at the domain. Does our graph go left? Does our graph continue to go right? So yes to both, so that means it's all reals. Or negative infinity to positive infinity. Alright, our range. Does our graph continue to go down? Yes. Does it continue to go up? Yes. Not as fast as it goes left and right, but it's still continuing to go up and down. So here again, our range is all reals. Alright, another example. Alright, this one has a break in our graph. Alright, so let's do domain. There's a break at -2. So that means our domain, we can also write it as an interval in our set notation like this, x such that. Alright, so we're going to the left, so x is less than -2. Notice it's less than because I want to skip over the 2, and x is greater than -2. So in interval notation, I want to go negative infinity to -2. I can combine these by using a little u, and then go -2 to infinity. our range. All right, this time we skip over -1. So y such that y is less than -1 and y is greater than -1. So in interval notation, it's going to be -infinity to -1 union -1 to infinity. All right, a couple more. All right, domain on this one. All right, notice that we have a starting spot here. Looks like about -4, and then it's going off to infinity. So in set notation, x such that x, we include -4, so it's greater than or equal to -4. Interval notation, -4 to infinity. We include -4, but it's open on infinity. Our range, all right, we start at -2 when our graph is going up. So our set notation, y such that y is greater than or equal to -2. Or -2 to infinity. Include the -2, we're open into infinity. So I'm trying to show you a lot of different examples. All right, look at the domain of the following. Okay, domain. If we drop down, looks like it's hitting about -3. It has a beginning. It also has an end at 6. All right, notice there's a discontinuity at x equals 2. Our graph jumps. It's said to be discontinuous at x equals 2. But there's still no break in our x, so we can write our set notation x such that it's between, we include the -3 and we include the 6. And then interval notation, we go -3 to 6, and we want to include both of them, so they're closed on both ends. All right, range. Let's look at our range. So it starts here at 2 and continues up to 3, 4, 5, 6, 7. So our y, it's between 2 and 7, and we include both. So finally, like I said, interval notation, we were between 2 and 7. All right, one more example with domain and range. All right, this time, remember there was that asymptote here at 3, x equals 3. So here our graph starts at -3, but we don't include it, and it goes to infinity for our domain. So our domain is going to be x such that x is greater than, it's +3. All right, doesn't include the 3. So interval notation is going to be 3 to infinity, but we're open on both ends because we don't include the 3. It gets really, really close to 3, but doesn't include it. All right, but our range, our graph continues to go down and up, so there's no restriction on our range. So y such that it's between positive and negative infinity. Or negative infinity to positive infinity, both open. All right, increasing and decreasing intervals. When you're reading a graph from left to right, the increasing interval happens when the graph is going up. And the decreasing interval happens when the graph is going down. Turning points or horizontal lines are neither increasing nor decreasing. All right, a couple of things you remember. We're always in terms of x. when we talk about increase and decreasing intervals. And they're always open. So we're going to be using parentheses only. They're open. And we'll talk about that as we go through it. All right, so the way I like to do this is mark my turning spots first, reading from left to right. So this is like a snippet of a roller coaster that we're going to use that has lots of up and down hills. So it starts at 0, and then it's going to change direction at about 1.5. We're going to estimate right now. And then we change direction again at 2, again at 3, again at 4, and then again at about 5.5, here again, which is estimating. And then finally, we're going to stop this particular piece that we're looking at about 6.5. All right, reading from left to right. Going up is increasing, so I'm going to go plus for increasing, and going down is decreasing. So I'm just going to go through and put the plus and minuses. So down, back up, and then finally down. All right, now we just need to write our intervals. Remember, they're open parentheses, because at these turning spots here, we're just waiting for something to happen. We're neither decreasing nor increasing. All right, so our first increasing interval, since we started at 0 to 1.5, then we're going to start increasing, and we can connect them with that U again, 2 to 3. And then finally, our last interval increasing is 4 to 5.5. Our decreasing intervals, 1.5 to 2. The other one's 3 to 4. And then finally our last one is 5.5 to 6.5, because this is where we could choose to end our particular graph. It could go off to infinity if we were doing a function. All right, another example. All right, mark your turning spots. So now here this goes off to infinity, so that's negative infinity. Here we have 1, 2, 3, 4, 5, -5. Another one at -3, -1, 1, 4, 5, and then we're going to positive infinity. All right, go through and put your pluses and minuses. So we're decreasing, increasing. All right, horizontal line, nothing. We're neither increasing or decreasing. Right here, we're increasing again. Then we decrease for a bit. Increase, and then horizontal again. So that means we're not doing increasing nor decreasing. All right, let's list our intervals. So we're between -5 and -3, positive, -1 to 1, and then finally 4 to 5. All right, decreasing. Our first decreasing goes from negative infinity to -5. And then we don't have another one until, 1 to 4. And that's our only other decreasing interval. All right, finally we have left is end behavior. The end behavior of a function is the behavior of the graph of f of x as x approaches positive or negative infinity. So literally that, we're looking at the ends, the arrows. We don't care what's happening in the middle. So we're looking at only the ends of our graphs here. So look at it in words and symbols. As x approaches negative infinity, that's the left-hand side of our graph, what's f of x doing? What's y doing? Well, it's pointing down. Down is negative infinity. And in symbols, we're just going to go negative infinity. All right, as x approaches positive infinity, the right-hand side of our graph, what's f of x doing? Well, it's going up, so that's also positive infinity. or positive infinity in symbols. All right, look at example B. As x approaches negative infinity, the left-hand side of our graph, what's the end behavior doing? It's going up in this case, so that's positive infinity. Or positive infinity in symbols. And as x approaches positive infinity, the right-hand side of our graph, what's f of x doing? It's going up again, so that is also positive infinity. Or positive infinity. Okay? Alright, so let's sketch a graph whose end behavior is as follows. Alright, we want, as x approaches positive infinity, we want f of x to approach negative infinity. So we know the left-hand side of our graph is going down in the end behavior. And as x approaches negative infinity, the left-hand side of the graph, f of x approaches negative infinity. So both ends are going down. Now the middle, it could do anything. It could turn around once, it could turn around several times, as long as the end behavior follows that. All right, if you have any questions, please let me know.